We're going to go from this to this. Welcome to Doing Stuff with Darren. I'm Darren. Let's do stuff. Today, I'm going to show you how to convert your 15-pound manual Hakka sausage stuffer to electric. It mostly works. Watch until the end and you'll see what I mean. Let's get started. Let's go through all the components you're going to need to complete this build. The links on where to buy all this stuff is in the video description. First, you'll need a 12-volt power supply. This is a 30-amp power supply. Next, you'll need a momentary foot switch. This one allows you to choose if you want it to be normally open or normally closed. We're going to use it normally open. You'll need some connectors to attach the foot switch to the stuffer. You'll need some 10-gauge 12-volt power cables. These are 10-gauge number 8 ring connectors. This is a momentary switch. This is a rotary encoder. It has a push button as well. You'll need a knob for it, as well as two 100 nanofarad capacitors. You'll need this perforated board to solder it to. You'll need 12 number 4 wood screws, 3/8 of an inch long. I got these at Home Depot. You'll need a 3-wire servo cable. This one is 20 centimeters long. This is a 2-row 16-character LCD screen, also called a 1602. This is the I2C backpack that came with it. You'll need an Arduino Uno. Make sure the one you buy has these little holes to solder to. And it also needs this group of 12 holes down here. We'll be using these too. This is a 30-amp DC motor controller. This is made by Cytron, and it's an MD30C R2. We're using this one because it can handle all the power supply and motor can use, and it's currently in production, so you can buy it. The other controllers I looked at, like the Victor 888 and the Rev Robotics Spark, aren't in production anymore, so you'd have to find one on eBay, and I figured for this project, using something you can get easier is better. This is a windshield wiper motor. I've already soldered the power leads to it, and I'll show you how I did that later in the video. A full description of this motor can be found in my Motorize Your Sausage Mixer video, so rather than recap all of that here, you should go watch that video. You'll need 4 M6x25 screws. These washers came off of the stuffer with the screws we're replacing. This is one of those screws. You'll need to use it. It's an M6x12 panhead screw. These are 4 M6x20 screws. You'll need to get 3 M6 washers to go with them. These are 1/4 bolts I got at Home Depot. You'll need 2 that are 3/4 of an inch and 1 that is 1.5 inches. You'll need 4 1/4 nuts. Now let's go over all the stuff you'll need to 3D print. This is the motor housing that fits on the side of the stuffer. This is the motor control box that sits on top. This is a 1/2 inch to E16 adapter. This is the motor lock that keeps the motor in place. This is the 3-to-1 planetary gear set. There's 4 planets and 1 sun gear. This is the planet carrier for that set. This is the 4-to-1 planetary gear set. Again, there's 4 planets and 1 sun gear and a planet carrier. This is the ring gear that attaches to the motor. It fits both the 3-to-1 and 4-to-1 gear sets. This is a 1-to-1 adapter that fits between the 4-to-1 sun gear and the stuffer. You would use this if you're stuffing bigger sausages. Lastly, this is the adapter that fits on top of the stuffer rack to press the limit switch when it gets to the bottom of its travel. That's everything you need for this project. Let's build it. Let's start by getting the components ready. First, we'll attach the power cord to the motor. Take one of the 12-gauge 12-volt power cords and cut it in half. You'll attach one leg to the ground pin on the motor and one to the high-speed pin. Again, these are discussed in more detail in my Motorize Your Sausage Mixer video. It doesn't matter what color wire you attach to which pin, as we'll be adjusting the motor direction in the Arduino code later. Next, we'll put the rotary encoder together. For this, you need the perforated board. What you need is a strip that's 3 holes wide. So we'll score the board with the razor and then snap it off. We'll put the rotary encoder in the center of this strip and then bend the tabs underneath to hold it in place. The side of the rotary encoder with 3 prongs is the rotation control, and the side with 2 prongs is the button. The center prong in the rotation side is the ground pin. On the button side, it doesn't matter which one you make the ground because the button just connects the 2 pins together. So we'll solder the controller to the board and then take a little piece of blue wire and connect these 2 grounds. Next, we'll cut 4 pieces of wire 8 inches long. We'll solder the blue wire to the ground. We'll solder the green wire to the other button pin. Then we'll take the yellow and white wires and attach them to the rotation pins. Next, we'll take the 2 100 nanofarad capacitors and we'll attach them between each of the rotation pins and the ground. Lastly, we'll snip off the unused edges and we're done. Now we'll put the LCD screen together. We have to solder the I2C backpack to the screen. Then we'll bend the pins of the backpack upwards so the new screen will fit in the enclosure. We'll cut 4 wires 7 inches long. We'll attach the blue one to the ground, the white one to the VCC, which is the 5-volt in, the green one to SDA, and the yellow one to SCL. Then we'll put heat shrink on them. Next, we'll wire up the top limit button. This button has 3 pins. There's a common, a normally open, and a normally closed. We're going to use the normally open and common, so that when the button is pressed, it closes the circuit. We'll cut 2 pieces of wire 4 inches long and solder them to the normally open pin and the common pin. Now we'll wire up the connector for the pedal. We'll need 2 pieces of wire 9.5 inches long. We'll solder these to the connector and heat shrink them. Next, we'll wire up the pedal itself. I got this pedal on Amazon. It has 3 wires, a common, a normally open, and a normally closed, so it's just like the top limit button we've already done. There's a diagram on the bottom of the pedal showing you which wire is which, but I checked them with a multimeter just to be sure. Here we see that if we connect the white and the red wires and we push on the pedal, then the multimeter makes a sound indicating continuity. We'll solder those to the other side of the pedal connector, and then we'll wrap it with electrical tape for reinforcement. The last component we need to get ready is the 3-wire connector. All we have to do is snip off the female side and strip the wires a little. Now it's time to start connecting everything to the Arduino. We'll first connect the motor controller wire. The black wire goes to ground, the middle wire is the motor speed control and it goes to pin number 10. The white wire is the motor direction control and it goes to pin number 7. This is where you want to attach them to the Arduino. Next, we'll attach the rotary encoder. You want to connect the ground to the ground pin down here on the bottom row. Now we'll take the button wire and connect it to pin number 8. Lastly, we'll connect the rotation wires to pins number 2 and 3. It doesn't matter which wire you connect to which pin, because if the encoder is turning in the wrong direction, we'll fix it in the code later. Now we need to connect the top limit switch. It connects to pin number 4 in the ground. Then we take the pedal connector and it goes to pin number 12 in the ground. Next, we'll connect the LCD screen. As you can see, it has 4 pins labeled ground, VCC, SDA, and SCL. If you look at the Arduino, it has a row down here with the same labels. So we're just going to connect these wires to that row. This is what that looks like when it's done. The last thing we need to do to the Arduino is connect power wires. These are each 9 inches long. We'll connect the red one to VN and the blue one to ground. Now the Arduino controller is done. Let's get the power and motor wires ready. I took a 12-inch long 10-gauge connector and cut it into an 8-inch piece and a 4-inch piece. Then I put 10-gauge number 8 ring connectors on the ends of each of them, so we ended up using 2 12-inch lengths. The one that we attached to the motor earlier was about 6 inches, so we're left over with one 6-inch piece. Let's put the Arduino into the motor controller box. The first thing we have to do is thread the LCD screen, the rotary encoder, and the pedal connector through the hole in the side of the box. Once that's done, we can lay the Arduino in place and screw it down using four number 4 3/8" screws. Then we'll thread the limit switch up into its hole on the top and put its washer and nut on to hold it in place. Then we'll pop the top back onto it. Now let's take a closer look at the motor control board. The only modification you have to do to this board is take this jumper at the JP6 input and switch it to the bottom 2 pins. What that does is it tells the motor controller that we're going to use an external source to tell it what speed to run the motor. Now what you see is the motor output and the power inputs are at different heights on this board. The board goes into place with those outputs lining up with the holes in the box. We screw the controller down with 4 more number 4 3/8" wood screws. We'll connect up the power input. This is the only part of the whole project where we actually have to pay attention to polarity. The motor controller is marked with a plus and a minus sign. We'll use the short connector we made earlier. We'll connect the red wire with the positive and the black with the negative. When we screw these in place, we'll add in the power wires to the Arduino. Then we'll plug in the 3-wire cable from the Arduino to the motor controller. Make sure you plug it in with the ground wire connected to the ground labeled on the controller. Lastly, we'll screw in the motor output wires. Now everything is wired up, so the next thing we have to do is set the contrast on the screen. The way we do that is we have to plug it in. This is very important. You have to make sure that the wiring is the right polarity. The 12-volt source has a positive and a negative, and you have to make sure you connect the positive up to the red wire on the motor controller. We're also going to connect the computer up to the Arduino. Now let's switch over to the computer. The first thing we have to do is upload the I2C scanner program to get our LCD screen's address. Here you can see it's 0x27. Next, we're going to open the Stuffer program. The link to the Stuffer program is in the description. For this program to work, you're going to need the Liquid Crystal I2C library. The download link for that is also in the description. If you have issues downloading these things, watch my Arduino meat thermometer video. I go through how to do it all in detail there. Now let's take a look at the Stuffer program. Make sure to put your LCD screen address here. Mine is 0x27, so it's already correct for me. Now let's go back and look at the LCD screen. It doesn't show anything. That's because the contrast screw isn't turned correctly. So we'll take a screwdriver and turn the screw until we can see the writing clearly. I don't show you this in the video, but I also unplugged to the computer at this point and made sure the writing had the correct contrast with the Arduino being powered by just the 12-volt source. Let's finish building the Stuffer box. We'll attach the LCD screen to the motor mount box using 4 number 4 3/8" wood screws. Then we'll take the rotary encoder and thread it through the side hole and put a washer and nut on it. Then we'll put the knob on it. When we put all this on the Stuffer, we need to make sure we lay the pedal wires in this little groove running down the side like that. Let's put all this on the Stuffer now. I've already removed the 4 screws from the side of the Stuffer, and I've removed this 1 screw from the other side. We'll lay the pieces on top and we'll attach the single screw side first with an M6x20 screw and the washer that was on the screw from the Stuffer to begin with. Now we'll put the motor box on using 4 M6x25 screws and we'll try to center it as best we can. Next we'll raise up the plunger using a ratchet and the 1/2" socket adapter. Next we'll attach this top adapter to the Stuffer using the 1/4 20 by 3/4 inch bolts and nuts. Then we'll take the 1/4 20 by 1.5 inch bolt and we'll slide it up from the bottom and lock it in place with a nut. The way you adjust the height of this bolt is you attach a ratchet to the slow speed of the Stuffer. Then you slowly lower the plunger down. You want to hear a click from this button indicating that it's reached its contact limit before the plunger gets all the way to the bottom. So let's go ahead and do that. We're lowering the Stuffer. There's the click of the button. and it can go that much further. So I know that that plunger can't bottom all the way out without first hitting the limit of that button. Now let's finish up with the motor. We'll attach the ring gear to the motor using M6x20 screws and washers. Now let's look at the two sun gears. The larger gear is the 3:1 ratio sun gear, and the smaller one is the 4:1 ratio sun gear. We're going to use the 4:1 for now. So we put that on the motor shaft and secure it using one of the M6x12 panhead screws we took off the stuffer in the first place. Now we'll put together the planet carriers. The planet carrier with the thin studs goes to the small gears in the 3:1 sun gear. The planet carrier with the thicker studs attaches to the larger planets, and this is the 4:1 gear set. We'll pop the planets onto the carrier and put the carrier into the ring gear. We'll raise the stuffer plunger up about halfway by hand, and we'll slide the motor on and turn it into place. We'll hook the motor up to the motor controller. Let's plug the pedal in and connect the stuffer to the power supply. The first thing we'll do is check the rotary encoder direction. I want it to go up when I turn it clockwise and down when I turn it counterclockwise. Here you can see it's doing the opposite of what I want. We'll fix that in the program. Now let's check the motor direction. We want the piston to go down when we press the pedal. Here you can see that it's going down when we push the pedal, so the motor direction does not have to be changed on this one. If yours goes the wrong direction, I'm going to show you how to fix it. Let's switch over to the computer. Here is what you change if your motor is going the wrong direction. Mine is right, so I'm going to leave it alone. But if it were wrong, I would make forward equal to 1 and backward equal to 0. This is the part you change if your encoder is turning the wrong way. Mine is wrong, so I'm going to change it. I'm going to make encoder pin A equal to 2 and encoder pin B equal to 3. This last part is what you can change if you want to change how long the stuffer reverses for when you let your foot off the pedal. The default is 2 seconds, but you can change it if you want. Now we'll upload the program and check it. Okay, here you can see that the encoder is now turning the right direction. It's going up with clockwise and down with counterclockwise. So the stuffer is now done. Let's go test it out. I put some food-safe grease on the gears. Then I ran the motor with the 3:1 gear set in it. I'm making brats and hog casings, so I think the 3:1 is going to work best for that. I put the motor on and put the motor lock in place. The rotary encoder button is reversed. You can see when I press it, the plunger is moving upward. It's quicker to take the motor off and raise the plunger with the ratchet, however. Here is the first run of the stuffer. I started it at 100%, and you can see the meat comes out pretty quickly. I then turned it down to 70%, and that was a more comfortable speed, but as I got the hang of it, I turned it back up to 100. It's a little fast. Let me turn it down. If you listen carefully, you can hear the motor auto-reverse when I let off the pedal. The auto-reverse is set for 2 seconds as mentioned earlier. I may change it in the future to 3 or 4 seconds, we'll see. The problem with making the auto-reverse longer is that there's no top limit switch, so if you accidentally hit the reverse when you're loading the stuffer, it could get up too high and break the gears. I did 25 pounds of brat with it without a problem. The motor got a little warm, so I don't think it's going to have a 100% duty cycle, but I bet it's at least 30%, which would be fine given the time it takes to put casings on and refill the stuffer occasionally. Let's move on to snack sticks. Here I have made a 10-pound batch of snack sticks with a 5% water ratio. I'm using the 4-to-1 gear set. I put the motor on and locked it in place and plugged everything in. I'm using a 10mm tube and 17mm bearded butcher casings. And this is where the problems started. It worked for a second and then it wouldn't go any further. On examination, it turned out the inside of the sun gear stripped and the motor was spinning, but the gear wasn't turning. So I took the filled stuffer cylinder and put it in the fridge while I printed another sun gear. This time I printed it pretty much solid. After an hour of printing, it was back for round 2. I put the new sun gear on the motor and reassembled the stuffer, and okay, that's going pretty fast. Oh, something broke. There you go. I thought I broke the stuffer, but it turns out it was the planet carrier that broke this time, so here I am breaking the weakest link one by one. When I printed all these parts out, I printed them with some standard settings on my 3D printer because I didn't know how much stress they'd have on them. I have now printed the sun gear and planet carrier pretty much solid, and I've beefed up the planet carrier design somewhat. I don't have any more snack sticks to make this weekend, so I'll plan on tweaking my recipe and making another batch next weekend. I'll post an update when I do that. We'll see if I'm successful then or if I just break the next weakest component. Stay tuned. Alright, that's all I've got for this video. I hope you've enjoyed it. If you have, do me a favor and hit the like and subscribe buttons. I'll see you next week. I hope you have a great rest of your day.